In our next chapter, we are going to discuss polynomials. And the first section, we're going to focus specifically on adding and subtracting polynomials. Now, I do want to remind you of a couple of definitions from previous work that'll apply here in this first chapter or this first section. So a term is a variable, a constant, or the product or quotient of a variable and a constant. And we also know that terms are separated by addition and subtraction. We learned this way back when we start talking about linear equations in one variable. We start by talking about algebraic expressions and terms specifically. So an algebraic expression is a combination of numbers, variables, and operations. And back when we were in that chapter, we learned that with algebraic expressions, we could do two things. We could evaluate an algebraic expression for a specific value for the variable, or we could simplify the algebraic expression by combining like terms. So kind of start thinking like that again, because it's going to come into this section nicely. Okay, topic one, the focus of this video is describing polynomials. So we have several definitions. Hopefully a couple of them are familiar to you, but if not, just pay close attention. So a polynomial is a single term or the sum of two or more terms containing variables with whole number exponents. So that whole number exponents piece is important. So remember this, whole number exponents. Now, the next definition is that of the degree of a polynomial, which is something that you need to know. So if a is not equal to 0 and n is a whole number, the degree of a polynomial of the form a times x to the n is n. So when you have a polynomial, we're saying that we have some polynomial a, some number, times x to the n power. Whatever that exponent is, as long as it's a whole number, that becomes the degree of that term, okay? Or that polynomial if you're dealing with a single term. So the degree of a non-zero constant would just have an exponent of technically 0. So you kind of have to go back and think of a few things, and we'll talk about this much more. But if I were to have something like x squared plus 5x minus 3, each of these terms in this polynomial have a degree. The degree of this term is just a 2 because the exponent is 2. The degree of this term is 1 because even though we don't write it, there's technically a little 1 here. So the degree of that would be 1. So then the question is, well, what in the world do we say about a constant that's all by itself? Well, we would say that the degree of this constant is 0. So the degree is 0, the degree is 1, the degree is 2. And so we'll learn in another section how to deal with, well, maybe it'll happen here. We look at the degree of the entire polynomial. So when we're looking at the degree of the entire polynomial, we want to look at the degree of each individual term, and whichever degree is highest, that becomes the degree of the entire polynomial. Okay, so just notice that when we're talking about this right here, this is what we mean, kind of looking at this situation here. If you have a constant all by itself, we say it has a degree of 0, that term does. Now, to write a polynomial in standard form, write the terms in order of descending powers on the variables. So, for example, the polynomial that I just gave you, that was technically in standard form. If I had something like 4x minus 2 plus x squared, this is not in standard form. To write it in standard form, we would look at the exponents and put them in descending order. So I would write this x squared, and then remember 4 times x has an exponent of 1 on the x, so I would then go plus 4x. And then constants have a degree of 0, so we would write minus 2. So that would be standard form, okay? Now, the three definitions that you might kind of remember from previous math classes, a monomial is a polynomial that has exactly one term. A binomial is a polynomial with exactly 2 terms, and a trinomial is a polynomial with exactly 3 terms, okay? So let's look at example 1. So example 1 here says, write each polynomial in standard form and then state its degree. So remember, when you're looking at the degree of a polynomial, you look at the degree of each individual term, and then whichever one of those is the highest, that becomes the degree of the whole polynomial, okay? So first, part A, we have 3 minus 5x plus x squared. We want to start by putting this in standard form. So to put this in standard form, I would get, well, x squared has the largest exponent, so I would start with that. Then minus 5x has the second largest exponent, and then you always end with a constant. The degree of the first term is 2. The degree of the middle term is 1. And the degree of the constant, remember, the degree of a non-zero constant is always 0, okay? Next up, we have 8x To the fourth, oh wait, I didn't state the degree of the whole polynomial. Let's go back to part A. I got an email and I got sidetracked. So when you're looking at this, we have the degree of the first term. We're still in part A. The degree there is 2. The degree of the middle term is 1. The degree of the constant is 0. So the largest degree of an individual term is 2. So we would say the entire polynomial is degree 2. Okay, now let's look at part B. So part B, we have 8x to the fourth minus 125x to the second power. If I look at the exponents, they're already in descending order. So this one is already in standard form. So now I just want to look at the degree of each individual term. So the degree of 8x to the fourth, well, we know that the degree of the individual term is going to be that of the exponent. So we would say the degree here is 4. When I look at 125x squared, the exponent is 2, so that would be the degree of the second term. So then the degree of the whole polynomial is going to be the highest degree of any individual term. So the highest degree of an individual term is 4. So this polynomial has a degree of 4. We would say it's a fourth degree polynomial. All right. And then part C, we have x to the third minus 2x squared plus 9 minus 5x squared. This is definitely not in standard form, so let's go ahead and take a minute. We're going to write the terms in basically descending order of their powers. So x to the third, that does have the highest exponent, so it will stay first. But then negative 5x squared is going to be second because it has the next highest exponent. That's a 3 there. And then we want negative 5x squared. Now we have negative 2x and 9. Negative 2x has an exponent of 1, and then we always end with a constant. So that is now standard form. So this is standard form right here. And then the degree of each individual term, well, the degree of the first term is 3. The degree of the second term is 2. Remember, when you have a single term like that, you just look at the exponent. The degree of the third term is 1. And then remember, if you have a non-zero constant, its degree is just 0. So we always want to look at the highest degree of an individual term. That would be 3. So this is going to have a degree of 3. So it's a third degree polynomial. So there you have it. Make sure you understand the different individual types of polynomials, because a lot of times I'll say monomial, binomial, trinomial. So know what I mean by that. Understand the definition of a polynomial. It's very similar to an algebraic expression. We just need to make sure our exponents have whole numbers. When we're talking about degree, understand what that means. And then when we look at the degree of a whole polynomial, we just look at the degree of each individual term. And the term with the largest individual degree, that becomes the degree of the whole polynomial. All right.